So, continuing on now in this second segment of the same screencast, we're looking at the principle of separating gradually. Now, in this case, it's similar to separating in time, except that instead of looking to change a property either all at once or even in its entirety necessarily, we're looking at situations where we're either continuously changing a property over time or at least changing it in discrete increments over time. So the first aspect of separating gradually is this notion of repeated use. And the example that they give to help illustrate this is a lap pool for a long-distance swimmer who wants to train without having to do a lot of turns, but without occupying a lot of space. And so the water can simply be recirculated over and over in a continuous fashion at a speed that's commensurate with the speed at which the swimmer is going. The next area within separating gradually is maturation or proliferation. And this looks for some element of a system that's capable of self-organizing. A common example of things that are capable of self-organizing is life forms. So looking at plants, say in a landscaping or gardening context, there are times when you plant something that tends to produce increasing amounts of shade as it grows, amidst other plants that tend to require increasingly more shade as they grow. And thus striking the right balance for the plants that require shade, while also making sure they get the necessary sunlight that they need when they're smaller. The next example of separating gradually is separate use. This is the example that they want to give for separate use here is a series of small explosions, such as to aid with demolition or excavation. You may need, for various reasons, to use small amounts of explosive at each point, but their accumulated effect can be as large as is necessary for the particular application. The next area is gradually merged. So the example that they give for this goes back to one of their favorite recurring examples is the pile driving situation. So in this case, what they propose is that instead of having a thick pile that you drive, that you have to balance between having it be the trade-off between thick and or blunt versus thin and or sharp. So you can make very thin piles that are much easier to drive, but you drive them one at a time so that when they get into position, they accrue to create the effect of a thick pile. And so you'll see this also spills over into the issue of sharp versus blunt, because a series of sharp piles that has many separate and distinct points is not as detrimental to stability as one single big tip. So the next area, scrolling up on the right column here, is merging or interaction. Now, this is similar to the gradually merged, except as you saw down here in gradually merged, we keep adding the thin piles, and together it forms the sort of collective equivalent of a thick pile. Whereas in merging or interaction, the components that are already there actually contribute to transforming the subsequent elements that get added to the system. So with the piles, the piles that were already in there weren't actually changing the new piles. It's just that the sum of all the thin piles was having the collective effect of a thick pile. But here, if we think about trying to heat up a bunch of pieces of metal, instead of heating them all up together, which would take longer and require more net energy, if you heat them up one at a time, the pieces that are already molten, you can then place subsequent pieces inside that, and as you submerge those, the already melted pieces can contribute to hastening the melting of the subsequent pieces. And of course, this isn't linear, because the more you melt, then the bigger the pool in which to put subsequent elements. But the key is that the elements that are already there and the changes they have experienced help to induce similar changes in subsequent additions. So the next area is gradually hidden or gradually exposed. This is a situation in which every element in the system has both the desirable property and the undesirable property. And they can be configured in a way that allows the undesirable property to not be exposed in a way that would subject it to whatever disadvantage that undesirable property would normally cause. So the example they give for this is tanks. A kind of tank that is protected on the front and not protected on the back, at least unless there's some other form of protection that's available. So they can be arranged in a way that alleviates this problem by having them circle up so that their backs are up to other tanks, sort of in a radial fashion, and minimize any disadvantage from having an unprotected side. The next area in separating gradually is called gradually transformed. This is also they don't call it this, but this is also an area of separating by condition. Remember, within separation in time, there was an area called separating by condition, and so this would be analogous to that if we were also classifying it that way. But I think this is actually a very good example. It goes back to the pile driving example again, and in this case, what we have is the blunt pile with a sharp tip, but that tip is made of an abradable material. That is, a material that erodes as it's used, and it's designed to erode quickly. So it's sharp while it's being driven into the ground, and the sharp part gradually wears off and is designed to wear at a pace that would cause it to be completely gone once the pile has reached its desired depth. Now, to clarify how this might be designed in real life, you might be thinking that the tip would be the first thing to abrade, and so it would actually lose its sharpness pretty quickly. But there are actually materials that wear anisotropically, so that it can actually preserve its essential shape and shrink in a proportional fashion until it's completely worn. The next area, and the last area within separate gradually, is called gradually added fields. Now, if you imagined that instead of sharp it just said A, and instead of blunt it said B, and instead of uncooked it said A, and cooked it said B, basically the generic form of the abstract depiction graphic that they use for this category of separate gradually would be the same. They have two squares and an arrow going from one to the other. The only difference here is the dotted line around it. And that's because what we're gradually doing here is adding a field, that is changing something in the environment or in an adjacent or surrounding element that's not a core or primary element of the system. And the example they gave here is cooking food. So we're gradually changing a thermal field to transform the food from uncooked to cooked. Okay, so that's basically it for separating gradually, which can, in a sense, be thought of as a variation on separating in time. It's just that it's a big enough subset that we give it its own separate treatment as a different separation principle, but it's very closely related to separation in time, if not a subset of it. So going on then to a more qualitatively different type of separation principle, we're going to talk about separating in space. So we turn to separating in space when it becomes clear that our product absolutely has to have two conflicting properties at the same time, and there's no amount of hashing through the principles of separating in time or separating gradually can get us out of that fact. We are stuck having to have those two conflicting properties at the same time, and that's when we then turn to separating in space. So at the beginning of when we were talking about separating in time, we asked ourselves whether it was absolutely necessary that our product have the same these two conflicting properties that we need at exactly the same time. And if the answer was no, then we tried to find a solution in the separating in time principles. So similarly here, we have to ask ourselves, okay, we know because we're here that these two conflicting properties we're trying to reconcile must exist at the same point in time. But do they have to overlap in space? If yes, if they must overlap in space, then you go on to the next principle, which is separating between parts and the whole. But if they don't necessarily need to overlap in space, then we stay here and go through these various techniques to see if we can find a solution. So the first major area within separation in space is two objects. Now, you might remember this from separation in time. We also talked about two objects. In that case, I think one of the examples was sandpaper, where first you use a coarse grain for getting the right shape, and then you switch to a finer grain to get it to your desired level of smoothness. In this case, we're separating in space with two objects because they're not necessarily for the same application. In the context of separation in time, we knew we were going to have to use both pieces of sandpaper on the same piece of wood, one after another, to reach our desired endpoint. In this case, a good example is a construction site sprayer, where we have different nozzles that we need at different times for different purposes. So you need to be able to have heavy droplets in order to wet the ground. You need to be able to have a fine mist when you're trying to settle flying dust. So as long as the nozzle is interchangeable, then you can achieve either of these goals at different points in time for different applications in different situations. The principle of extraction is a little different from two objects, because although one object is functionally extracted from the rest of the system, they interact in a way that they don't in the two object situation. So for example, these two nozzles, you use them in different situations and they don't interact with each other. Whereas if in the example of a magnetic stirrer, and we have a contradiction between wanting to have the stirrer in the acid, in this case, so that it can mechanically interact with the liquid in order to stir it, but you want to have it outside of the acid so that it has a long life and doesn't erode. And so we split it up. We have everything except the stirring bar outside of the acid, and just the stirring bar in the acid, and then the magnet spins to spin the stirring bar. So you may also recall that extraction was discussed in the context of separating in time. And there we use the example of an extendable and retractable fuel nozzle for aircraft refueling. And in that case, again, the temporal relationship was much more important because it has to extend, get fueled, and then retract. Here, the temporal nature of when you're extracting and retracting is not so important, because during the entire functional use or functional life, it remains extracted. Next, with mixture, we're combining elements that have different properties together in some way, such as with a composite material or an interweave or perhaps a laminate material. And one prominent example of mixture is when you want multiple paths or multiple options for different paths. The example that they give here is a circuit board. Typically, in circuit boards, you want the shortest path possible, especially when you're dealing with high-speed circuits where timing is of the essence. But there are times when you want a longer path, and so you sometimes design circuit boards to have multiple paths. One that goes, say, directly through the board, and one that goes sort of around the board. It looks like they show that here. You can get from here to here, either directly by going through the plane, or less directly by going to the end and then wrapping back around. The next area within separating in space is called interact, although they add also guide, nestle, and penetrate to that. And the basic idea here is you have two different components of a system that each provides a conflicting property, and you're able to configure them so that those two components with their two conflicting properties interact in a way that you get the benefit of both without the drawback of either. So in this case, they use the example of a spring inside a housing. So you need a light spring with a low spring constant for a particular application, but you need it not to buckle when it's compressed over long distances. So you have a rigid housing, see here, and you have the light spring inside, and that way you get the benefit of both. So the principle of attached objects is somewhat similar, except that there's no interaction between the components. So that's how it differs from the previous one. And it may also make you think of a carrier when you think of attached objects. Back from, we talked about a carrier back in separating in time. But with a carrier, remember, we have a component that's temporarily lending its property to the whole system, or to at least to another element in the system, and then being retracted when that property is no longer needed. So here we have two properties that are needed at the same time. An example they give is a toothbrush. We need the bristles to be stiff. At the same time, we need the handle to be rigid, but we don't need the bristles to be rigid at the same time as the bristles are stiff, because we don't need the bristles to be stiff at all, just like we don't need the handle to be stiff at all. Therefore, it's a great candidate for separating in space, and in a much simpler fashion than in the interactive one that we just looked at. Also note that attached objects differs from two objects in the sense that with the two objects, such as with the different spray nozzles, we're using them for different applications in different situations, whereas with attach objects, it's to bring those two different properties together for the same situation. So you're not needing the heavy droplets out of the hose at the same time that you're needing the fine droplets out of the hose, but you do need to be able to hold your toothbrush by its handle at the same time that its bristles are cleaning your teeth. All right, now the next principle within separating in space is partly carried. Now, with partly carried, we're talking about a situation where we're using a carrier that's permanently part of the system. It's not like carrier in the sense that we used it before, where it was temporary. So it's permanently part of the system, but only for some of the elements in the system. And the example they give here is a book with a binding. So we need the pages to be stiff in order to be controllable, and we need them to be flexible in order to be turnable. And so we have a binding which allows us to have some amount of control over the pages that are not being turned, but that does not stiffen the pages that we do want to turn. Now, of course, we have soft cover books where instead of a binding, we essentially just rely on the pages that are not being read to aggregate to create sort of a binding of sorts. But I think there are variations on this example that would actually make it better, like devices that actually hold or prop a book open. There are things that sit on your desk and hold a book open to a certain page, and even things for treadmills. I think that might crystallize this one a little bit more. But in principle, a binder or even the sort of pseudo binder of having a large paper black book with all of the other pages sort of acting as a binder can sort of make the point. Now, partly merged or interacting. This one is sort of a combination of separating in space and separating between parts and the whole, which we'll talk about next. In this situation, some parts having one property interact or merge with other parts and take on the opposing property. Any parts remaining retain their original property. So in this example of radiation treatment for tumors, we have a contradiction between needing them to be high intensity in order to kill the tumor and low intensity in order to not kill surrounding tissue. So the way this is resolved is by having multiple low intensity beams which all intersect at the point of the tumor, and therefore the intersection is the point where the intensity is heightened, and we have low intensity in these other surrounding areas here. Next, with non-uniformity, we're dealing with a situation where there's a single element that has both conflicting properties that we're trying to reconcile or coordinate. The transformation devices are a common example of this, because you have one property at the input and a conflicting property at the output. And devices that transform energy are a particularly good example of this. So with a lever, we have high force and low displacement on one side, and low force and high displacement on the other. The next category within separating in space is called facsimile, and other authors call it modeling. And this is when, well, they give the example here of taking a high-speed video of a bullet in flight, so that you can see how it either proceeds on its trajectory or approaches its target, which is not possible to see live. So basically with facsimile or modeling, you're changing some property, in this case speed, in order to be able to examine or experience some aspect of it that you wouldn't be able to in its true form. Next, selective countering is when you're blocking an action or a force in one area of a system and not in another. So the example they give here is in a football play where you want the line to hold in order to protect the quarterback, but you also need to allow the ball carrier to get through. And the last category within separating in space is separating on condition. And unlike when we talked about separating on condition back under separating in time, in this case we're looking for two different locations at the same time that provide two different conditions that can be coordinated in a way as to satisfy both objectives. So the example they give for this is called boat mooring. That's when you want a boat to be in the water so that you can fish or what have you, but you want it to be fixed or anchored so it's connected to something on shore or otherwise affixed so that it is not just free to float anywhere.